So what I'm going to talk to you about today is something that I think many of us struggle with, but we don't quite know how to articulate. For those of you that have gone to many of the sessions, it's actually probably unearthed more questions than necessarily answers. And I hope to give a few points that might be helpful. Ernst Young indicates that there are probably 45% of the companies in any given industry that can potentially become obsolete and just simply vanish. And do you know what the greatest challenge in companies around the world is? And I can tell you because I've traveled quite extensively. And it's this fear of being disruptive that actually leads to immobilization. So instead of choosing to be proactive as an organization, they actually resist. They think that by resisting, they're actually saving their jobs, when in fact they're actually sealing their fate. And collectively, this mindset of resistance leads to companies dying. If you look at the history of Fortune 500, 88% of Fortune 500 companies from 1955, and let me transition to that slide here, are no longer on the Fortune 500 list today. Most of the blue chip companies only stay at the top for about 10 years or so. Then new companies take their place, like that of Snap, Google, Apple. I'm writing a book called Strive. And it's about how doing the things most uncomfortable leads to success. Now, this concept doesn't just apply to individuals and corporations, but also to governments. I'm originally from South Korea. And I don't know if you know this, but we were actually a colony of Japan for 35 years. And those were some dark and tough times. And our prospect as a country didn't actually get much better after the Japanese rule and World War II. And the reason for that was we transitioned right into a civil war called the Korean War. And perhaps some of your relatives or your parents were involved in it, fighting. Well, the Korean War decimated our country from 1950 to 1953. And by the time the armistice was signed on July 27, 1953, we were not even one whole country, but only half of a peninsula, which is what South Korea is today. And we were one of the poorest countries in the world. And in 1960, our GDP was nothing more than $79 USD. That's lower than most African countries. In 2015, South Korea's GDP per capita was $36,612 USD. And it ranked in the OECD and the G20. And we became one of the most technologically advanced nation in the world, with the highest percentage of college graduates in the entire world. So the question then becomes, how did we do this? How did this happen? Intentionality. Let me repeat myself. Intentionality. Doing the things that's most uncomfortable to transform a nation. And it started with building new industries from scratch. And instituting higher education as one of the most important factors in building a human capital intensive economy. I can tell you it was a lot of sweat and hard work. And there were no shortcuts. To go from being one of the poorest countries to becoming a top 10 OECD nation in less than 40 years was no easy matter. Everything about it was uncomfortable. Did you know that, according to PricewaterhouseCoopers, their annual global CEO survey, 62% of CEOs express concern about the impact of disruption in their industry. And it's coming from all over, from the likes of Internet of Things, AI, machine learning, data analytics, blockchain, decentralized computing, to quantum computing, if you were at my previous session earlier today. Unless we as governments, industry leaders, academia, unless we take action now, many companies, including your companies, economies will be in danger of becoming irrelevant and obsolete. I was an economics major, and the thing that my professor used to always refer to was the buggy whip. You can make the best horse buggy whip, but once the automobile came, that buggy whip frankly wasn't useful anymore. The World Economic Forum survey gives us a hint on where the future is going and when potentially we would have arrived in that so-called future. It's things like having a robotic pharmacist, when your clothes are internet enabled, when AI is sitting on the board of directors. McKinsey noted that there are 12 key industries or areas that are experiencing seismic shift in their approaches. Every industry is being affected from disruption, from the likes of manufacturing, pharmaceutical, healthcare, automotive, telco, oil and gas, you name it. The primary drivers of this type of change are the intelligent software systems, such as AI, machine learning, as well as Internet of Things and cloud computing, advanced robotics, autonomous vehicles, next-gen genomics, to energy storage and 3D printing, advanced materials, and so on and so on. And these disruptions cannot be stopped, and if you think that they can be slowed, you guess wrong. Because those that have lived through the mainframes, the servers, the internet, the mobile, more and more these innovations are happening faster and eclipsing faster. When I consulted Samsung just 2-3 years ago, they were desperately trying to figure out how to replace their cash cow mobile phone because it died so quickly. Well, these disruptions are going to have some significant implications. Not only are they going to be unstoppable, but it's going to change us. Some of you that are sitting here may be displaced. Hopefully not permanently, but it will. The automation, the intelligence of these systems will lead to a net 7% loss in US jobs alone by 2025. Now, if you think these jobs are only in manufacturing or retail jobs and things of that nature, you're actually wrong. And the reason is they have the potential of replacing everything from marketing and sales, of course admin, professionals, to even management. Yes, including lawyers, consultants, you name it. Matter of fact, if you've heard recently, there is a project that's out there that's taking all the available snippets of code and using AI to assemble a set of applications that a typical entry programmer would have done. So how are we as companies, industries and governments going to not just be simply disrupted, but rather become the disruptor? Now this is our framework for transforming not just companies, because we're consulting to nations all over, including the European Commission, as well as places in the Middle East. It's about starting with futurism on the bottom, then incrementally moving up to R&D, experimentation, investment, implementation to knowledge transfer. It starts with envisioning the future. Now this is vastly different from saying, oh, I know what the technology trends are. Just slap on AI and that's going to disrupt our industry. No, no, no. That in itself is not a sufficient condition for guaranteeing the creation of a new, vibrant industry or the fact that your company is going to be relevant. Rather, when we say envision in the future, it requires a special future casting ability to visualize how we as people will work and interact with one another in the future. And it requires an unbounded imagination, creativity, and forecasting the world and how we need to start preparing for it today. Now, this is exactly why we're actually working with DARPA, which is the R&D arm of the US military. They work on shoot the moon research projects. Did you know that most of the technologies that you and I take for granted, the likes of the internet, the mobile phones that you're holding, satellites, VR glasses, to name a few, all originated from the likes of military. And they're not just interested in AI, they want to know what comes after AI. And that's where we're going. If you attended my earlier session on quantum computing, I explore how quantum physics is evolving into quantum computing, and it's providing us this potential to solve some of the greatest challenges that we face in IoT that you heard today, like security, privacy, interoperability, and so forth, right? But what if I told you that quantum computing can support quantum teleportation? Not physical you being teleported elsewhere, but data. How will that change everything from telecommunication, broadband, internet, mobility? What about security? Using quantum computing qubits to solve integer factorization, using the Shor's algorithm for cryptography, to break traditional classical security programs that all of us depend on today, to actually building unbreakable security. And I'm not stretching the truth. Unbreakable security, such as the use of quantum key distribution to distribute completely random keys at a distance. R&D. Then it's translating that future casting to advanced research in IP and patent developments. Because if you think that the solution to IoT is IoT sensorizing, collecting data, and you're done, you miss the entire boat. It has to be first and foremost about intellectual property that is uniquely yours and cannot be replicated by your competitors. It's not good enough to look for white spaces in the patent landscape, but it requires integrating the future envisioning with the development of advanced technologies to determine the why, the what, and how things will be disrupted. I don't know if you realize this, but countries and industries are in a race to develop intellectual property and patents. As of 2014, China ranks tops with over 900,000 patent applications, followed by the US, Japan, and South Korea. They know that the future of their economies and their competitiveness depend on IP development. But it's actually not good enough to just futurecast and file a bunch of patents. Because you have to prove out your hypotheses and technologies. It actually requires translating those deep insights and research into functioning systems that actually work. That validates your hypotheses, and more importantly, you validate with the market to ensure market fit. For instance, in the oil and gas industry, we're working with a company called PolyInspect out of Saudi Arabia to develop an infrared thermal imaging robotic crawler with multi-sensor systems to inspect the integrity of reinforced thermal setting resin pipes. In other words, non-steel pipes. Because steel pipes had corrosion and they're starting to get old, and we need to replace it with something that's much more durable and lower cost. there's a massive opportunity to apply your regions and the Europe's region deep expertise in the sectors of such like manufacturing and CPG and many other sectors that all of you are involved in. But this is where we not only organically incubate innovation and technology, but also look outside to figure out where are the best of breed technologies, including those that's coming from the likes of Silicon Valley, London, and other parts of the world. It also requires a disciplined investment approach in conjunction with your regional R&D and your firm R&D to broadly capture these opportunities. And in many cases, some companies are playing an active role in investing and in creating an ecosystem. Implementation. We then apply our organic R&D and the portfolio of startup technology as well as your technologies to create and enhance your set of product portfolio to begin that transformation. Now this phase, of course, is the hardest because, well, it's squarely about execution, isn't it? Well, more and more companies are expecting 10x return on investment, especially when it comes to the Internet of Things. See, the problem is, if you've attended some of the sessions today and yesterday, many of the IoT platforms that are available in the marketplace are too expensive to implement and to maintain. And companies like yourselves are saying, we have to find something that's open source or something that's open platform and not become a hostage to our vendors so that we don't get negatively affected on the CapEx and the OpEx, which is an important piece. Now this is where we have worked with a company out of Silicon Valley called Ray Labs, and they bring an entirely different solution to markets. Their solution has garnered the attention of DARPA, Department of Homeland Security, and SoftBank, and utility companies. What they've done is they've actually compressed down on the left all those tiers, those multi-layered stack of IoT platforms into a unified, simplified, yet concurrent and parallel processing platform that can actually sit on the edge as well as sit on the cloud. And it's been optimized specifically for a certain type of ARM chip to be low energy, which is becoming a heavily important set of requirements. And more importantly, aside from the compressed down and simplified footprint, they have security that almost in a way makes that IP-less. And they have the capability to handle edge-based data analytics. Human capital. I mean, of course, it's involved in all these stages of the entire framework. Specifically, what we're pointing out is the knowledge transfer and the skill development components. Because as we all know, unless we're on the sell side, when the consultancies, when the vendors come in and do their work and implement and maintain, did it actually enrich your labor force, your teams, or are we still relying on everybody else? We want our local resources, we want our firm resources to be involved in the entire implementation phase alongside SMEs and soaking up that hands-on experience. Learning by doing is what it takes to deploy Internet of Things implementation for your company and the industry. And it's taking train-the-trainer approach that we then codify to create formal training content and processes so that we can intentionally disseminate more broadly that new knowledge among your team members in your organization. We want the goal to be the creation of your stronger, enhanced firms as well as new industries that are developed and supported by local residents and your firm resources. Innovating and executing well in IoT starts with reframing and doing the things that's most uncomfortable, because this journey is not easy. If you think it's just a matter of getting a bunch of sensors and MEMS and hoping that you're going to get data and all of a sudden you're in big business, you're wrong. It often requires really fundamental organizational change, culture, business models, change management. This transformation work is hard and expensive in time and effort. Applying a methodology helps to lift you and your teams up. From technically, putting these sensors onto machines to thoughtfully thinking about the future. Building IP that's uniquely yours. Experimenting, nurturing, growing, and then implementing. All the while ensuring that there's knowledge transfer that's going to develop your organization's capabilities. So with that, let me go ahead and transition to Q&A. Any questions before we head out to dinner? Questions, please?
When's your book coming out?
The question was around when is my book coming out. My book is scheduled to come out in early 2018. And I'm also writing a second book about man and machines and how we're going to coexist. Any other questions? Yes, sir.
Could you please say anything more about quantum computing? Because it sounds like too good to be true. These algorithms are going to be super fast, parallel processing.
So the question was around, can I speak a little bit more about quantum computing? That is exactly what we spent in the prior session in the other room for about 35 minutes. But I will be happy to send you my video as well as my presentation. What I would say in terms of expectation setting is that it's not going to solve all problems. That's not the point. But as the industry struggles with especially things like security and laying new infrastructure, especially in the context of smart cities, it gives us another possibility, another option for us to consider. Because it's not 20, 30 years away. It's more like 2 years for another set of more modular, extensible prototype. And then about 8 to 10 years, according to IBM as well as other researchers, for a full-out quantum computer. But it can address things like cryptography. It can address instantaneous messaging and communication, even if you were on this side of the universe and on this side of the universe. And this is exactly what China is experimenting with their quantum satellite communication system over the next few years. Yes, sir.
Sorry. A while back we were talking about a concept called digital Darwinism, where the digital world was moving faster almost than humans' ability to adopt the technology. In its current climate, with AI, with obviously Internet of Things being quite key, with lockdown, with all of these things that we're hearing about, do you see this as being accelerated? Do you think that sometimes the factor limiting adoption is us?
So the question was really oriented around the speed of technology innovation versus human adoption. And I think most of you would recognize that the technology is going to be always advanced than our ability to adopt, in particular your customers, right? Now with that said, there are some interesting points of kind of anecdotal data. While the likes of IBM and others have been pushing for AI and cognitive science, it's very interesting to see, especially on the consumer side, how Amazon has made Amazon Echo and the Dots, in particular Alexa, make it pervasive to those that are non-technical. They have no idea what it is, this notion of natural language processing, but yet they interact with it. And if you've been to the CS earlier this year, you know that the biggest story was really Alexa in everything. So I think it really comes down to how you implement it. Now, later, I think it's next month, I'm going to be speaking at the largest auto industry show in Detroit. And what's happening there is the auto industry is going through some major upheaval and changes. And I can tell you that some of them may not last. They will definitely have to consolidate because they're getting competition from new companies, including the likes of Google, Tesla, and other companies that you don't even know exist. One of the things that at least the auto industry does recognize is there's different grades of autonomy when it comes to automobiles. You can't just simply roll out number 5, the highest level. People are not ready to just let go. In the US, especially California as an example, we like being in control, and I have a feeling most of you, including Europe, like being in control. And regardless of the life savings and efficiency, you're not going to be at the mercy of machines right away. It's just like elevators. You need some time to trust the machine before you can start to kind of coexist, co-pilot.
I have one. Let's ask the audience the question. Last question.
Can you give us one or two use cases in how businesses and countries are using your services to enable IoT or digital transformation? And if a small startup is able to access your services, and if they can't, whether you can give some sort of information on how they should go about transforming themselves in order to succeed in this rapidly evolving technological world we live in.
Okay, I think I got some of it. The question really is around, can you give some use cases or examples of countries
Yes.
that are going through transformation? I'll give you two very briefly. I've spoke as well as interacted with the European Commission about a month and a half ago, specifically around the IoT framework for all of Europe and what's it going to take to spur the IoT development, not just within a sector, but across, what they call cross-cutting. Very important. We're actually in the process of advising the Kingdom of Saudi Arabia right now. They have a very urgent initiative called Vision 2030, which basically comes down to the fact that their oil reserve isn't going to last forever, maybe 25 more years. And not to mention the low prices of commodities has really affected their economy. So they're starting to diversify away from oil into non-oil revenue generating industries. The question then becomes, how do they that know so much about oil and gas go into new industries that maybe they have no expertise in? Well, that is exactly why we've developed this framework specifically to apply not just for corporations, but for nations. So we're actually working with the universities as well as with our entity to co-create IP and intellectual property patents, because we think that that is a key driver. More importantly, what they, as well as many countries, have not done very well is commercialize IP into businesses. We're going to actually put and institute a process that's going to systematically commercialize IP, whether it's from university, other startups, or corporations, or ourselves, and then show how we can actually follow this methodology to de-risk and actually groom and incubate not just silly startups like the Uber Eats, but real game-changing industries, changing logistics, transportation, infrastructure, buildings, and so forth. And from there, incubate, get it to be a monopoly within that region, and then get to a point where it can start to export out.